Thanks, Rachel.
Hello, I'm going to start my lesson by remembering certain things from our previous lesson. Remember in the previous lesson I showed you how to make up compounds from their elements. For example, if I give you this compound is water. Water consists of two elements, hydrogen and oxygen. As you can see here, this is the hydrogen, that's the oxygen. So it consists of two parts of hydrogen and only one part of oxygen. I would like for you now to let me know what's the simplest compound that you can think of in your mind that you can synthesize from its elements. Is there something that you can think of from anywhere?
Oxygen.
Very good. Oxygen. Good job. You did just great. Oxygen is a little compound that is formulated by the two atoms of oxygen. That's why that 2 is right on the right hand side. It is the subscript of the molecule. So excellent. So now let's build on this knowledge today and learn about the phenomenon called osmosis. Okay, let me show you what I mean. I'm going to take these down. And we're going to pretend this is the biological membrane that you can find in your cells.
Okay.
Molecules have the tendency to want to cross that membrane in order to get inside the cell. This is the inside of the cell, that's the outside of the cell. Now you might be wondering, why do I need to know this information? This is very important information because you see it in the hospital. Anytime that the doctor is administering a drug and wants to observe the results of that drug, he or she is basically looking to observe what will happen 48 hours after the administration of that drug. Will that drug be able to cross the biological membrane and get over to the other side in order to observe its effect and its action? Okay, so we're going to start with something very simple. Pretend that we are starting with a very, very small molecule. This one, chlorine. Chlorine wants to cross the biological membrane. Will it be able to, and why? I'm going to guide you first. This is what we have to think.
Okay.
What kind of molecule is chlorine? Is it a big molecule? Is it a bulky molecule? Or is it just a small molecule? I'm asking you the question. Please respond.
Small.
Very good answer. Excellent choice. Since chlorine is a small molecule then, we anticipate it to be able to cross over to the other side. Okay, well, chlorine is going to do just that. It's going to cross over to the other side and it's going to get into the cell. Now chlorine is inside the cell. Now I'm going to show you something else. If I have a molecule such as this one, this is called methanol. Methanol consists of 1 carbon atom, 4 hydrogen atoms, and 1 oxygen. When you see this atom, you go, wow! Will this molecule be able to cross the biological membrane? Yes or no? What's your first inclination is no. And why is that?
Because it's big.
It's big. It's too big. It can't cross the biological membrane. And that's how the body wants to react towards it. It doesn't want to allow such bulky molecules to cross over because that's going to upset its equilibrium. It's going to upset its homeostasis. And the body doesn't want to go through that.
Yeah.
Okay? So we leave that molecule over here, outside of the cell. If we need to transport it later on, we have to do it with special proteins. For now, this molecule is going to stay outside of the cell. Okay? Because if we wanted to transport it, like I said, we would have to facilitate active transport. Okay? Which is not what we want to do right now. Right now, we want to do diffusion, which is passive transport. Okay, now I'm going to show you another molecule, which is a neutral molecule, very familiar to all of us. This one is what? Water. Very good. Excellent. So we learned all of our biological molecules, the most common ones, at least. Water. Looking at water, we drink water, we see water in the world around us. 3/4 of the world is made up of water. So what is water going to do?
It's gonna cross.
Very good. Excellent choice. Very good. And it's going to cross because
Because it's small.
it's a small molecule. Compare it to methanol. Doesn't it look a lot simpler?
Yeah.
Yes. So it makes sense. Now, let me give you 3 other molecules, and you will be able to tell me whether or not they will cross the biological membrane. Okay. Bear with me for 1 second. I need to be able to put them on my magnetic. On my magnets. Got this one. I'm giving you these 3 molecules. This is iodine, this is benzene, and this one is ethanol, the regular rubbing alcohol. Okay, so now you can tell me which one is going to cross and if anything, what happens to the others. Okay, very good. And you knew that, why?
Because it's small.
Very good, excellent. Excellent rationale.
Ethanol won't.
Yes, very good. It's too big, it's too bulky, right? And what about this guy here? This guy is a hydrocarbon, yeah. There's no way the cell is gonna say, yeah, come on in.
Yeah.
No way, just stay out there. It's safer for the cell, right?
Mm-hmm.
Great job. Now that you understood all this, I have a checklist prepared for you.
Okay.
I'm gonna give you 7 molecules.
Okay.
Some of them I have introduced to you before, and you're gonna be able to put them on the list. Please make sure that you put the ones that will cross the biological membrane. This is the barrier. Make sure that you list those right here on one side, and the ones that will not cross the biological membrane, you will list them on the other side.
Okay.
Okay? Now, what you just learned is called osmosis. Osmosis is the phenomenon of crossing over across a biological membrane.
Okay.
Okay? And you learned the application of osmosis, which is actually seen in the hospitals.
Okay.
All right. Okay, go ahead and take a couple of minutes. And I'm going to put the molecules up here so that you can see them all. They're going to be right here. There we are.
Okay.
Okay, let me see. All right, just for a second. This looks good, 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 very good. Excellent. Now you have actually reinforced the concept of osmosis and you can apply it to real life.
Okay.
Let's see how well you do by thinking about it. Okay, by thinking about how you will apply it when you see these substances, these molecules, in the hospital or in the laboratory. Okay? So take this quiz. It consists of 2 questions. Just try to think of what we said earlier. Okay, thank you very much. And let's see how you did. Yes, I asked you to list 2 substances that will cross the biological membrane, and you listed water and iodine correctly. And 2 of the substances that will not cross it, and you listed the bulky benzene, which is up here, and methanol. Very good, down here. Excellent. Thank you so much. This concludes the lesson. It was a pleasure teaching you. Have a nice day.